Okay, I'm going to spend a little bit of time talking about a subject that's very important to us at Battelle, and it's a lower cost and faster way to develop and test software for integration. It's from a white paper that we generated a few weeks ago on how Battelle would integrate autonomous control into a heavy construction grader. The situation I'll describe is where a customer wanted blade control or autonomous operation of drive and blade control. Now, there are commercial packages that are out there that do give you basic control of vehicle movement. But our experience has been these are closed solutions that really they don't give you, or they're limited to waypoint navigation, but they don't include things like obstacle detection and avoidance, or those higher level operator functions where the automated package is driving the system beyond its tolerances to where it will damage the equipment or hurt the operator or anybody around it. We initially looked at a semi-autonomous control for cost reasons. Everything revolves around cost nowadays. And it involved identifying a commercial package that was available that we could start with and then add on those additional functions that were necessary to meet the full-up requirement that weren't available in a commercial off-the-shelf package. We followed a three-phased design approach, starting with requirements analysis and then feasibility study of the commercial packages that are out there. Phase two is the most important part for us because it's really the most exciting part, and it involved rapid prototyping of the code and the algorithms in a modeled environment. Now, to do this, we used Battelle's software architecture for mobile systems, or what we affectionately call SAMS. It's a physics-based model. It was created by Battelle, and the beauty of it is that you can create in a modeled environment the code and then test the code at the same time within that environment. But more importantly, when you're testing that code, you're testing them over the same environments that you would actually test them in. So what that means, and when we say physics-based, it means if you're driving over a bump, you're going to get that same dynamic response. And so it's a very powerful tool. You don't have to integrate it into the vehicle and test. You can test it in a simulated environment. Now, not very many companies out there have this ability. Many companies have a SIL environment, systems integration lab, where they can take code that they've generated and link them with emulators and components and test the system that way, or test the software that way. They can't test it in a tested or an actual environment simultaneously like we can. We've got both of those capabilities all wrapped up within SAMS. Well, it's a very, very powerful tool. Now, what I've just described is a lower cost way to rapidly develop and test software for integration in autonomous capability using Battelle's software architecture for mobile systems, or SAMS. But it's not just limited to autonomous capability. Anytime you have a situation where you're trying to design software and test software for integration, you can use SAMS. So I'd like to get into a conversation with you on some of the issues that you have where you may be able to use SAMS, and we'd like to get an opportunity to talk to you about it and see if maybe there's a way we can help you. So give me a call.